Good morning. Welcome to the Phoenix Contact booth in Las Vegas at Pack Expo 2017. I'm Bill Shallon. This is Jeremy Valentine. We got a little bit of time to kill before everybody gets in the room here, so we want to make sure that we kind of let you know what's going on here at Pack Expo. Jeremy got in a little bit before I did. Do you have any interesting thing happen this weekend?
Well, it's Vegas, so there's lots of interesting, but apparently
and what stays in Vegas isn't supposed to go on Facebook, right? Yeah.
But it's been fantastic. The venue is amazing. For anybody who has the opportunity to come out to Pack Expo at some point, it's definitely worth the trip out. It is amazing. The campus here is just immense, and all types of machines, from small, large, a lot of stainless steel everywhere. A lot.
Food and beverage, big deal here, yeah. And it is a huge show. There's multiple halls that they've got going on, upstairs, downstairs, so it is definitely worth the trip down. A lot of interesting things to see, everything from how they package food all the way up to the machines that do that packaging.
Yeah, exactly. So, yeah, with that, it'll probably be about another 30 seconds or so, and then we'll kick it off here and walk you through.
30 seconds? That seemed like only like 10 seconds. Wow.
That's funny. It felt like 3 hours.
Cool. So it is. This is our third year, I think, doing Pack Expo. So it's very good. We've got definitely a plan that we're going to try to do a consistent message over the next couple of years. We tied this in with IMTS too. So we've got two different shows that we try to do the same audience for. Phoenix Contact has been doing this for even before that for years, doing packaging machinery stuff.
So with that, you want to head back and take a look at the booth?
Are we ready for that yet? Or
are we good?
Cool.
All right, fantastic.
All right, well, welcome everybody else. We're going to take back a look at it. Basically what we've got here is we've got an application. We're thinking of a traditional conveyor application where you've got some process aspects to it and all the good stuff that goes around with it. The aspect that we're trying to convey here is cabinet confidence. That's the theme we've had for a couple of years going on now, where Phoenix Contact can provide all the components that will make you more confident in your cabinet design and enable you to supply a better solution for your customers. So the first thing we'll do is Jeremy's going to talk a bit about power reliability, and then we'll move you through the rest of the booth.
All right, come on back, Paul, and all of Facebook world. So, as Bill mentioned, we do have a conveyor application that we're depicting here in our 10 by 20 foot booth. And really at the outset of all this, before anything gets operating, everything starts moving, belts start moving, anything like that, lights start blinking, it all starts with reliable power. And that's why we chose to highlight this first and foremost up front. So here what we're doing is we're bringing in 120 volts from the field, if you will, and bringing it in through a through panel connector here, and I'll show you exactly what this all means in just a second. But this is our 120. We're going to bring it into a surge protection device, which is right here. So if you have any transients, lightning events, or things like that, this is going to give you that first level of protection. We then bring that 120 into our UL 489 breaker, feed it into a small electrical port, and then what we're doing here with this device is simply monitoring that 120 volts. So we can see here we're at 119.1 volts. You can see 1, 2, and 3, and simply what that means is if we had a three-phase power source, you could monitor the power of each one of those phases. This also does harmonics, frequency, all this type of stuff. Long story short, this device here gives you monitoring capabilities of your energy, of your power, and this is something that continues to be an emerging trend here in the US. We've seen adoption of energy monitoring throughout Europe, and it's really starting to take home here. So definitely, if you're not already monitoring your power, this gives you a level of protection or a level of insight to make informed decisions about your machinery. And this is definitely something we're going to continue to see more adoption in the US. So with that, we're taking our 120 and then bringing it into a 24 volt power supply. And on this entire rail here, really what we're showing is a critical power application. And the reason really you can tell it is, without knowing anything, critical, is that we've got two power supplies here with a blocking diode in between. So if we have any events downstream, maybe an inductive load or whatever, this blocking diode will then protect the other power supply that doesn't take the hit from getting damaged. We've then got it backed up with a universal power supply, a UPS with an extended battery. So again, I mentioned critical natures, making sure you've got clean 24 volts. So let's go back up to this incoming 120. I mentioned it, and just in case you guys didn't believe me, we're gonna pull this guy out. And what's going to happen here is up here at our energy monitor, that's probably the best place to see it, this was running on 120 volts. It's now offline. This is a non-critical device. You don't have any power, you don't need to monitor your power. But downstream, we can see that the power supplies have shut off, but we're now in battery backup mode. So this is supplying 24 volts to those critical devices. So for example, if we jump up here, sorry to make you walk all around, Paul, but pretend this is our controller instead of just a simple monitor. If this was running our process downstream, you would want to do a controlled shutdown rather than just have the lights go out at some point. This gives you the ability to do it, to phase out and sequence all your machines in a phased way that is less impactful for the overall operation. So with that, we then take that 24 volts, distribute it out. We've got a passive device here that gives you a multi-legged distribution of that 24 volts. And this little guy here is just an electronic fuse breaker, or electronic circuit breaker rather. And it is pretty cool in that each of these 4 channels can be independently programmed for a different current rating. So what I'll show you right here is if we press this LED down, we can see as this guy blinks, it's going to blink 1 time, meaning it's a 1 amp rating. And just to show you, next in line, you have to hold for 2 seconds and I get antsy sometimes. If we drop down here, you'll see on channel 2, you'll see 4 blinks. So this guy is programmed for 4 amps. So channel by channel, it gives you the capacity to set your current ratings. So with that, we've distributed the 24 volts, bringing it in 120. We'll go ahead and plug this guy back in. Start up the whole system again. This energy monitoring device comes back online. We've got our clean power coming in. That's all protected, now distributed, and we'll kick off over into the control realm.
All right, now as we move further down our conveyor application here, the first aspect you have to consider whenever you're building a cabinet like this or a system like this is the kind of controller that you're going to be using. So what we've got here is one of our axial line controllers. This would be the programmable logic controller that is actually running the application here. So we have a certain amount of I/O that comes into it. So we've got digital and analog I/O that can come into this device. It also runs off of 24 volts and it's an Ethernet enabled device. So we'll be able to talk Ethernet, whatever protocol you want to use, to the rest of the system we have here. So what we're really trying to illustrate here is the collection of data from either digital points along the conveyor via SAC cables, and this would be a sensor actuator of some sort that's out there, or via an analog. So on this side we have analog signal conditioners that come in. So the signal conditioner acts as a buffer between the analog signal coming in from the signal, from the system. In this case we have a tank that we're illustrating here, so we have a level sensor we're bringing it into. Or you can have if you have some kind of a critical application where you want to isolate the signal, you can use a signal conditioner to do that too. So it'll give you some kind of galvanic isolation in between the world and your PLC so that you make sure that it's protected. So now as we're bringing the analog signal into the signal conditioner, it's coming into the PLC. The PLC is digitizing it and then firing it as output. So as I raise this up, you'll be able to see that the digital outputs fire, indicating the analog signal that's there. So as we get all the way to the top, we'll see all 16 of them fire, or actually 32 coming down. Good. The next aspect we have on here is that whenever you have a localized controller, you want to have some way to have an operator interface with it. That's what we're illustrating here with an HMI. This HMI is a localized control. We also have one that's remote further down. What this illustrates here is the ability to stop the conveyor, manually intercede with any kind of operations you need to do. So if you need to reset the conveyor, reset packaging on it, that's the way you'd interface with this here. And this is connected via Ethernet to the controller, and it acts as another input device for the controller itself. The next aspect you have, since you do have men and machines working together, is we have to go some kind of a safety device to help protect those people, and that's what Jeremy will come in and talk about next.
All right, thanks, Bill. So I'm going to have you walking all around, Paul. So as Bill mentioned, this is our safety story here, and though relatively small in terms of the overall framework of the entire panel layout here, when you think about machine safety, especially in the world of machinery and packaging, they're really sprinkled throughout any type of process. So here what we're trying to simulate here is just a simple robotic cell where you may have an operator or some personnel interacting with the machine that may be automated. So what we set up here is a light curtain which would then trip this light curtain is fed into our sensor actuator box and then into our safety relay. but really to set up that if you were to break this light curtain, you will then get indication over here, Paul. So you can see we've gone from all green, and this really just gives you a warning. So typically in a real application, you're gonna have some kind of audible alarm, some buzzing, something annoying, really to alert the user or the operator that, hey, something's wrong, get out of there. But you'll see in this, even though it is running and you get this warning, the conveyor is still running. So this is a big part of this. So this is where the e-stop comes into play. So again, light curtain and now e-stop all tied into the same safety relay. If we hit the safety relay here, you can see now we've got the conveyor stopped altogether. So something bad happened, we want to clear the load, maybe the boxes or whatever. And then up here you also have an additional alarm on the stack light where this is now red. So then if we just pull out the e-stop, maybe everything's cleared, we go green, and then the conveyor is operating once again. So very simple application here, but the cool thing here is you've got two safety elements run into the same safety relay, so you get a multifunctional relay here. Very slim in nature, supplied with power from our Uno power supply here, e-stop, and you're good to go. So once we move from maybe a robotic cell, the next story we're going to transition into is that of connectivity, which really encompasses a whole lot of different stuff, if you will. So Bill.
Like Jeremy said, connectivity is really one of the key elements. It's the history of Phoenix Contact. It's also one of the key elements with any application you're going to do, because you've got all these distributed signals that you have to bring back into a controller to make the application work. The premise behind any application is you've got to collect data, you've got to act upon that data, and then you've got to push it back out and make something happen. And that's where we're at right now, where we're trying to collect data. We saw it before with the controller, but now we're actually a different type of data here. We've got a sensor actuator box where we're bringing in outputting a valve sensor there, where we also have an inductive proximity switch here that as we drop in the metal piece next to the proximity switch, you can actually see the indicator on the sensor actuator box illuminate, letting you know that you do have a signal. This is great for local diagnostics, so if you're trying to figure out if a sensor is actually working or not, you can actuate it this way. That will condense the signals and then bring them right back into our controller here. So this would be a localized distributed I/O, again sitting on Ethernet. The Ethernet will go back to the main controller and allow you to condense signals into one location. Another thing that we have happening here too is we've got the ability to bring in some legacy devices. A lot of times when you have a conveyor out there, especially something that you're trying to retrofit, you'll have a legacy serial device out there. So what we've got here is a serial barcode scanner that comes in through one of our new Gateway products. So what the Gateway product does is that Gateway actually allows you to convert the legacy serial signal into Ethernet, and then the Ethernet signal is coming back out to the controller we have here. The controller then is acting on the packetized data from the barcode scanner and actuating the stack light that we have up here. So back up a little bit, what we can do is kind of show you what happens here. So we've got a couple of barcodes that we do here. So as we read one barcode here, you can see that it goes with green for good. So do that one again, you can see there. And if we go red, it interprets the barcode as a bad barcode, so red for bad. All right. Once we've got all the data collected, we've got all the action going on with the processor, everything doing, the next step we have to do is go back to actually kind of where some of the heart and soul go with Ethernet IP to do a little bit more distributed I/O. Jeremy will kind of walk you through that part.
So here what we're telling is really a motor control story. And though the focus is on motor control, what I would quickly point out is that it's really all enabled with Ethernet IP. So what we've got, if you remember just a couple panels ago, Bill mentioned the master PLC, the Axial line, Ethernet IP enabled device we had upstream. Well, that Ethernet IP is then fed into our Ethernet switch here, which then communicates to this bus coupler. So it's our remote I/O device here that then allows the logic to be transferred from that master controller down to this remote block, and then allows all these functions to take place. So you can see our motor going forward and backward, and the control and the protection of those are all enabled by our Contactron hybrid motor starters. Now the interesting thing about this is if you're familiar with typical contactors and motor control devices, these look dramatically different. These have two different elements within them, both electromechanical and solid state, that allows us to shrink the overall footprint but get a much longer life expectancy of those motor switching devices. So very, very cool. Now, again, because of motor control, you're going to have a safety element embedded within it. So if something goes wrong and you want to stop that motor, this is where, again, our safety relay comes into play. So this time we're connected right to our e-stop here, and if we have an emergency of some sort, we hit, and here you can see again we've got a stack light here, now red, giving you localized warning. We've got our motor now stopped, and if you remember, we have the stack light way downstream there. That guy now is also red, just like when we hit the middle e-stop on the conveyor system, as well as the LED traces mimicking the conveyor application is also stopped. So we pull this guy out, you can see everything is then up and running again. So again, you get a little bit of everything within this story here, and to start it all off, just like every panel, it all starts with clean incoming power. So again, we got 120, power supply, switch, remote I/O, motor control, and safety, all within this little storage. So really cool stuff. Then it all culminates in our final panel.
So we've showed you kind of the classic control scenario that you're going to have, where you've got a localized system, you've got a conveyor, you've got all the I/O that runs around the conveyor, you've got motor control, you've got power distribution. But a lot of times what you need to do is you have a remote cell that may not be localized right with the conveyor. So you've got to be able to get communication out to that, whether it's an AGV that's running around, whether it's maybe a remote operator that needs to interface with the conveyor itself. That's where all this comes into play. So what we've got is we've got a PoE switch right here that allows you to power several cameras that we have got around the booth, and you can go into those from our website too. But what that would be is for monitoring. So if you're a supervisor that's remote to the application and you want to be able to monitor things, you have cameras strategically mounted so that you can see what's going on. So the PoE switch is what powers those directly. That comes into our M-Guard. So our M-Guard acts as a firewall for the whole system. So what's going on is we've got a bridge between the remote world where people are coming into it and the control that's going on the localized world here too. That way if someone comes in with a computer that may have a virus on it, they're not going to be able to bridge into this. It also prevents people from coming in and doing some kind of a malware attack onto the system too. So that's where the M-Guard's critical to that. On the outside of that, then we have another one of our controllers, and that is driving an application here that we have on an HMI. So as the HMI happens, so if we want to start or stop the conveyor, you can actually interface with it that way. If you want to switch it into manual or auto, you can do that, and then you can actually do different types of applications in there. So this lets you actuate different aspects of the conveyor, so that if you had to intercede manually into the automatic operation, you can do it. You can monitor all of it via the cameras, and you can make sure that everything's good. When you're ready, you can put the system back into automatic, and it goes. Cool. Also on this panel, we have the ability to talk remotely with like if you have a supervisor that wants to come in and collect data on the system, that's where we have one of our new FL1100 radios. What that does is that allows you to link up to here without necessarily going in and being able to do control. You can do monitoring. So you can select, grab a certain amount of data out, see what's going on, and do essentially predictive maintenance instead of reactive maintenance on that. Finally, down below, we have another way to bring data in. So we've talked about bringing discrete data directly in. This is one of our bus couplers, but it's an IP67 bus coupler. It allows you to machine mount I/O. So you don't have to worry about having a home run cable come back. It's an Ethernet connection back to the controller, and it's all real world I/O coming into it. It does the conversion from the real world I/O to the digital world and sends it back over an Ethernet signal to the main controller itself. So that's kind of a good look at a basic system. The final thing we want to do is talk about how you kind of pull this all together. You want me to do this? I got it. Okay. Yep.
So let's take another field trip, guys. All right, so up in front of the entire back wall, we have one of our demo islands. But if you remember, throughout the back wall, you got a ton of different products and things like that. And I mentioned early on, it all starts with clean, dependable power, then transitions over into control. So you kind of think about it from a body perspective. You've got the heart being fed in by the power supply. You've got the logic, the brain, if you will. But throughout all of this, all these different devices, you saw a bunch of wires and you saw DIN rail and things like that. Really the backbone of what allows everything to happen are our marking devices, our tools, all the things that make the wire management, the everyday maintenance and setup of any cabinet simple. So that's what we've got here. We've got a bunch of different marking options for you. In this case, we've got automatic shrink sleeve markers, which you can print Phoenix Contact, Pack Expo, then put that onto a wire, use a heat gun, shrink it down. Gives you easy marker and signal identification when you need to do some maintenance in the control cabinet. Then if you go back on the other side here, you get into just traditional tools. Again, it sounds kind of simple and mundane, but this really acts as, again, the backbone to facilitate the completion and maintenance of any solid, dependable control cabinet. And you can see a wide variety of all these different tools, from stripper, crimper type of tools, to just crimps, screwdrivers, and things like that. A little bit of everything is all sprinkled throughout the Phoenix Contact portfolio when you think about tools and any type of shop floor productivity devices. So after you get all your panel connected, barreled, wired down, marked, it all culminates in something like this. So I feel like every time I'm on camera, I get to walk around, which is, I guess, maybe good. So this is really what it all culminates in again. So this is our master control panel. And really it is a beautiful layout of exactly what Phoenix Contact is to you as control cabinet builders. We've got everything from control, marshalling, connectivity. Here we've got our power supplies. Again, more marshalling, connectivity, relays, safety relays, and everything. But the take-home message here is not, hey, we do control cabinets, but we have everything to give you within the traditional control cabinet to allow you to have the confidence to come look to Phoenix Contact for your one-stop shop of everything within it. So this is a great highlight reel of everything for those of you who may be a little bit unfamiliar with Phoenix Contact, or may only know of us for maybe kind of our bread and butter, our terminal blocks. We are a heck of a lot more, and we allow you to have that confidence to go into the world and service your customers and really give them something special. So with that, we are going to say farewell.
Farewell. Adieu.
Yep. And thank you guys, everybody, for tuning in. It really was a pleasure. Hopefully it gave you a good indication of what we are here at the show. Again, for those of you maybe a little unfamiliar with Phoenix Contact at a deep level, maybe it was a little bit enlightening. And again, I can't express enough, if you ever have the opportunity to come out here to Las Vegas to a Pack Expo, it is definitely worth the trip out. It's a fantastic venue, fantastic show, and I'm excited to get going.
Yep, so am I. Let's go. Let's
right.
get you out of here so we get people in business.
Yeah.
All right.
Thanks.
Take care.